Welcome back to Programming with Adam, and in this video we'll be looking at LeetCode questions. So in this one we are doing the climbing stairs, and the problem is how many steps, how you're climbing stair, it takes n steps to reach to the top, and how many different ways can you do n steps. And there is a condition here: you can either climb 1 or 2 steps at a time. So let's call them big step and small steps. So if you want to reach if you want to do n steps, in how many ways can you climb if you can only do a small and a big step? So let's think about so the solution is, I have the code solution here, as you can see. So there are, so how many ways to climb just a single step? Well, there's only one. How many ways to climb 2 steps? Well, you can either take 2 small steps or take a big step. How many ways to climb 3 steps? Well, you can either take 3 small steps, or you can take first a big and then a small, or a small and then a big, and then so on and so on. And then what you actually see, this is this, as you keep going, this sequence is what is called the Fibonacci sequence. And so we just have to implement a method to do that. I will explain in a moment why it is this Fibonacci sequence. The mathematical proof is here, but let's just talk about the algorithm. So the algorithm is, the idea is, to find the next number, you always look at the previous 2, right? So you have a 1, 1, and then the next one is 2, which is the sum of the previous 2. 3 is the sum of the previous 2, 1 and 2. 5 is the sum of 2 and 3. 8 is the sum of 3, and so on. So you always need the previous 2. So the best way in an algorithm to do this is simply by always keeping track of 2, and then from the previous 2 get the next 2. So if we like have a 1, 1, so we have to be able to convert that to 1, 2. The 1, 2 has to be converted to 2, 3. 2, 3 has to be converted to 3, 5, and so on. Let's see the general procedure. AB gets converted to B plus AB, right? Because the second number just becomes the first one. And then for the 5, for example, then you really need to add the previous 2. So that's the procedure, and that's exactly what's implemented, and that's why it works. So finally, let me just talk about why it is this. Why do you need to add the previous 2 to get the next one? And this is the proof. So let's say there are A ways to climb n steps. Someone have computed that for you. And let's say there are B ways to climb n plus 1 steps. Okay. So now the question is, so how many ways is there to climb n plus 2, right? So you can do it, you can reach n plus 2 from step n by taking one big step. So we are looking at the final step, and the final step would be, okay, let me just recap the idea. So the idea is thinking about what is your last step. Okay, so if your last step is a big one, right, then that means you have first reached n, and then you take a big step. So in how many ways do you do that? Well, you first need to get to n, which takes you a ways to do that, and then you take the big step. And the only other alternative is to finish at step n plus 2 is you take a small step. So in how many ways can you do that? Well, then you have to first reach n plus 1 steps, and then you take a small step. So that you can only do by first reaching by first reaching n plus 1. You can that takes b step, that can be done in b ways, and then you take the small step. So in short, that is exactly a plus b ways to do this. You first either you finish with a big step, first doing different combinations and then a big step, or there are b different combinations and doing a small step. So that's all. And let's just see my submission here. You see, this is by probably the best way to implement it. As you can see, 99%, 0.83, and space is like almost 100. So I'm pretty happy with that, and I think this must be optimal. So I will pause the video here.